In recent months, the intersection of graphs and large language models, LLMs, has become a hot topic in the AI community. The potential of combining these two powerful tools offers exciting possibilities, especially in the realm of retrieval augmented generation, or RAG. RAG systems enhance LLMs by integrating external knowledge sources to improve their responses. This article will explore the pros and cons of using knowledge graphs for LLM-based RAG systems and delves into insights gained from Jesus Barraza's book, Building Knowledge Graph. So the past month, I've been immersing myself into knowledge graphs.
I found this free ebook that essentially gave me ancient knowledge and glorious new purpose when I was, shall I say, cast out, defeated. I have grown in my exile. I've seen the true power of the knowledge graph. I've seen what it can do and when I wield it.
Okay, let me really sell you on the idea. You might have heard that the breakthrough idea that made Google win the search game in the early 2000s was their algorithm PageRank, named after the man himself. This is a type of graph algorithm. We'll come across these quite a bit on our journey. While the competitors were busy handpicking what people thought were important, Google let the graph decide. But that is only one side of the coin. The other side of the coin came later. That was knowledge graphs. Google added this powerful feature around 2012, and it's worked out pretty well so far. In tech, that's ancient history though. So why bring it up? Well, there's been recent excitement around graphs and LLMs, which I'm also excited to get into. But first, let me guide you through some interesting concepts, and then show you some concrete examples. And finally, we'll build some knowledge graphs. Here's some context. Most data structures are node-based. These nodes have certain rules of engagement that make them useful for modeling different situations. For example, queues are useful for task scheduling, and stacks are great for modeling undo-redo mechanisms. But graphs have the least amount of rules or constraints, which makes them the most flexible. This is, in my mind, their most powerful feature, because the real world is messy and you need something equally unconstrained to model it as is. But once you import this real-world data, what do? Maybe graphs are a little too flexible. So we add back a little bit of structure because actually it's going to help us organize the data so that we can get information that's latent in the topology of the graph. It's essentially the best of both worlds strategy. The flexibility to model any kind of data, but the ability to add some kind of custom organization so that you can gain insight from your data. Now, at this point, you could be saying, well, trees are a kind of graph that has these special constraints, like they have to be connected and acyclic. That is not the kind of constraint I'm talking about here. This organization of data often comes from the specific domain we're modeling. So if the mathematical constraint of trees are at a lower level, the constraint I'm talking about is at a higher level. This video is about knowledge graphs. So let's talk about what they are. They are a graph database first and foremost. Another way to say that is to say the underlying infrastructure is just a plain old graph database. What makes a regular graph database a knowledge graph is that they have something called an organizing principle. Organizing principle is a layer of data within the database that stores additional nodes and relationships that map meaning, categorization, and context. What is an organizing principle? Organizing principle is kind of what it sounds like. It's how you agree to organize your database, but it's not quite like a database schema. Well, the database schema is a very specific and technical constraint for the data. The organizing principle is more abstract. It gives information on how the data is categorized and arranged. In other words, the schema are things like labels, indices, and constraints on your database. The organizing principle is often another set of nodes and relationships that explain the primary data. This layer of data outside the primary data is often in the form of taxonomies and ontologies. Wait, but why? Why add another layer of data on top of the actual data? Well, for starters, it enables kind of information retrieval that would not be able to be captured without it. Like going broader or deeper into a topic. That would be an example of a query that a taxonomy allows us to do. They essentially help us define is a type of relationship. For example, a dog is a type of canine. Here's my idea. Essentially, all of my chats with AI are everything that I'm interested in and want to know more about, right? So all of that chat between me and ChatGPT are all text. I do a little bit of processing, extract all of the concepts from each chat. I do some scoring of each concept with respect to each chat and give it a salience score. Salience is how related that concept is to the entire document. Okay, then you have nodes called chats and nodes called concepts, and they're linked up. Now you get a bunch of taxonomical information and turn it into an ontology organizing principle. And a little bit of query magic, and you have yourself a semantic search that will always give you something related. Basically, if direct search returns nothing, then I always want to see something related. Speaking of related, recommendations. When I'm in a chat, I want to see related chats, kind of like a YouTube page. When you're watching a video, there's a bunch of videos that you might also like, because maybe I'm asking something I've asked before. And to try all of these ideas, I needed my own ChatGPT. So I made one. It's essentially a ChatGPT clone. So far, it works and anybody can use it. It's free. I mean, it's free to use the app, but you have to put your own tokens. Call it BYOT, bring your own token. Also, it's still in beta, so don't expect like crazy stuff. Parts of it I'm still working on. But recommendations. What if, when you're in a chat, it offers other chats that are similar to it? Essentially, the feature you may also like. And that would be a recommendation engine. The how of it is basically very similar to how semantic search works. Key piece being here the salience metric, so that we can compute the similarity at query time and rank the results in descending order. That's it. I was having issues with the Neo4j hosted database service. I think it's called Aura, because they don't allow you to install libraries like Neo-Semantics, which is a third-party library, which I needed. So I had to install my own Neo4j, and that took a lot of time. Also, I'm going to add text embedding layer into it, which should help with the question answering and semantic search. Like this video to learn more about that.